Hello and welcome to the Daily Space for today, May 27th, 2019. My name is Dr. Pamela Gay and I am your host for today, and I will put science in your brains and possibly cough at you. I am recovering from bronchitis, but I am here, and I have to give a deep, heartfelt thank you to Binary Blaze, our own Annie Wilson, for subbing in for me all last week, a lot of the week before when I was sick as a dog. Bronchitis is a bear. Stay healthy, everyone. I also want to do a special thank you to Annie, to our Instro, and to all the vets out there, no matter what your country of origin, for serving your nations this Memorial Day. So thank you, all of you, for your service. Now, on to the science. But before we do that, I want to remind you, as we head into June, that if you really love this show and you really want to help us out, please consider either subbing right here on Twitch, where you get the cool emotes, or pop on over to Patreon and consider being one of our supporters over on Patreon. It really helps us know how much money we're going to have each month to pay our bills, which is mostly paying Annie. So thank you for everything you do, all of you. And now on to the furry, yucky science. I very rarely use the word yuck to describe science, but in this case, what we're looking at in this image is a whole bunch of salt crystals that have formed around an extremely hot spring. This is a spring that is about 89 degrees Celsius, and growing within these salt crystals is a myriad of microscopic life. These are microorganisms that are 5 to 50 nanometers in diameter. This makes them about 20 times smaller than your normal average run-of-the-mill bacteria. These itty-bitty little tiny microorganisms are surrounded by needle-like crystals of salt. And this suggests that the nanobacteria are actually like helping shape how the salt deposits form as part of this geochemical cycle, which means that the microbacteria are actually like arming themselves with salt is too strong of a phrase, but there is definitely self-defense involved. Now, this particular hot spring that we're talking about, this is Ethiopia's Dal Ol hot spring. It is located near an active magma reservoir in a volcanic region, and as well as being like one of the hottest places on Earth, with average temperatures in the upper 30s, air temperatures with hot springs that are in the like upper 80s, low 90s centigrade. This is also an extremely acidic hot spring. It has a pH of 0.25. I don't think I've ever seen anything naturally occurring with that kind of a pH before. Now, all of this means this is like extremeophiles. And it also means that this particular setup is kind of like we think might have existed once upon a time on Mars. So the life here, which is currently being studied by Dr. Felipe Gomez of the Astrobiology Center of Spain, this particular life is giving us hints of how life once upon a time could, that doesn't mean it did, but could have existed on Mars. And all I've got to say is this is extremely hot science, and it's a bit yuck. So, folks, I just want to remind you, as I often have before, do not lick the science. Moving along to a story of stellar evolution. And pausing to cough. This really ugly chart is one that came out of a really beautiful data set, and I'm going to explain what it means. There is currently a space telescope going around the Earth called Gaia, and one of the things that Gaia is doing is it's making extraordinary extraordinarily precise measurements of the brightness of stars over time. This means that we're able to see how brightness varies with time. Now, for some stars, this actually allows us to get at the rotation rate, because the stars, just like our own sun, have sunspots. And the sunspots change the brightness of the star. So by watching how long it takes for sunspots to pass by, we can measure the rotation rate of these stars. And Gaia has been working to do just that, as well as measuring a whole bunch of other things. Now, the cool thing about this is we can get at the magnetic field, and we can get at the rotation rate, or at least we can get at how the amplitude of these brightness variations, which is tied to the magnetic field, vary. And what was expected was you'd have some stars that would have a significant rotation rate, would have a significant magnetic field. You'd have others that had a lower rate, a lower field. But that's not what we found. In fact, this new Gaia data has given us a completely new insight into how magnetic fields and the evolution of stars are directly related. And here I'm just going to read from the press release, because they said this more clearly than I can. Deeper investigation of this data showed that the high amplitude branch, these are the stars that have a high amplitude in variation tied to their sunspots. A high amplitude branch is populated by young stars that have not yet ignited hydrogen in their cores. So these are hot stars. They might have done some lithium burning. They might have done some deuterium burning. They're still in the process of forming. Stars in the low amplitude, slow rotator group are identified as older, unsaturated stars. So these are stars that aren't dominated by their magnetic field. They're not dominated by sunspots, and they're just normal everyday stars. Now, there's a third type that is newly identified in this data set, and they describe these as ultra-fast rotators. And the faster stars on the high amplitude branch are expected to be stars that are on the cusp of igniting the hydrogen burning in their cores. Now, what is going on here is you have young protostars that have powerful magnetic fields. They have material falling onto them. And at this phase in their evolution, they're rotating fairly fast, and they have a fairly low magnitude to their magnetic field. But then they ignite their hydrogen in their cores. They start rotating faster, so they move slightly to the left to a slower rotation period. And in the process, they also don't have as strong a modulation due to the magnetic field. Now, this is something we totally hadn't expected. And they go on to say, in the early stages of this contraction, the spin-up is prevented by the loss of angular momentum through the interaction with the accretion disk. So in young stars, you have the star's rotation and the disk of material coupled together. This When planets begin forming and the gas in the disk dissipates, the star then becomes free to spin up until the overall contraction phase is over. This means that having a planetary disk actually slows down how long it takes a star to ignite. So this coupling between planet formation, a star igniting into burning hydrogen, this is all new, and thanks to Gaia. This is a completely new result. It's going to take us a while to process this, a while to figure out how to apply this to all of our stellar evolution models, but it's awesome. Okay, so I'm going to move on from this hard to understand story to one that is a different kind of hard to understand. In this case, the hard to understand is this is a photo taken of the Starlink train of little tiny satellites that are currently working their way toward a new orbit, but currently just form a lineup of lights across the sky. And the thing that's hard to understand about this is Elon Musk said before this launched that these suckers would not be visible. And these suckers are totally visible. This morning, just because I wanted to make sure that this was still true as their orbits changed, I was able to get a report. This is about 3 hours old from Vishnu Vardhan on Twitter. And he says, just now, the Starlink train of satellites spotted above the Arabian Sea, visual magnitudes 5 to 6. So this is on the faint end of what your eyes can see in a dark site. 2 or 3 satellites, among them illuminated up to magnitude 1 or 2. Those are like the brightest things that you see. This is like the magnitude of the corner stars on Orion. So this is like totally visible. And a variety of different astronomers have been working, and in this case also amateur astronomers have been working to image them. Here we have images from Mike Lewinsky, who allows us to see that the satellites are slowly moving apart. You can see a pair of lines. And he captures this video. Let me rearrange my screen so that you can see the video. Come on, let me scroll. There we go. So you can just see this arc moving across the sky in the time lapse. Now, this is the first this is the first many dozen of these. There's going to be thousands. Planetary scientist Alex Parker over the weekend did some quick math looking at the orbit of these satellites. There are going to be some that are in lower orbits than the ones that we're looking at now, and also some that will be in higher orbits. When the entire constellation is launched, if they are the same make as the current ones, the Starlinks at any given moment are probably going to outnumber the number of visible stars that you can see with your unaided eye. Think about that for a moment. There will be more internet-enabling satellites that you can see with your eyeball than stars. This is going to be problematic. We're still trying to figure out all the ways it's going to be problematic, but it's going to be interfering with like all of our imaging. We're going to have to do a lot to try and correct for this, to figure out how to deal with this. It's just kind of annoying. And thank you, Deinzo, for the follow. Thank you so much. So yeah, Starlink. Now, my co-host on Astronomy Cast and the publisher of Universe Today put out a great idea. He basically called on Elon Musk to please put space telescopes above the orbit of the Starlinks. Hubble is not above the orbit of the Starlinks, not all of them. And to basically replace what we lost from ground-based with space-based. Now, while that's a great idea, we can't do everything from space. Like, we can't replace the multiple 8-meter telescopes in the Very Large Telescope. We can't build the overwhelmingly large telescopes or the extraordinarily large telescopes in space, but there definitely needs to be some sort of compensation. And just think about what this will be like for future generations. They're going to grow up constantly seeing just satellites buzzing overhead like some weird dystopian future. It is going to be a weird dystopian future. Now, if you too would like to see the Starlink satellites, Heavens Above has them in the system. I forgot to put that slide up. One moment, and I will add the information up on the screen. So Heavens Above is your place to go and get information on when you can see different space telescopes, different satellites, different, if it's in space and it can be seen, Heavens Above will tell you how to do it. So go check out Heavens Above, and you too can suffer the fate of seeing internet fly over your head. That's all I've got. That's all I've got, folks. Now, in other reminders, we have a project over on CosmoQuest. The goal of this project is to map the rocks, the boulders, the craters, all the way the expletive too many things on the surface of Bennu. And we have a deadline on this. Now, for those of you who haven't taken a look at this yet, let me pull it up. That did not go as planned. Hold on a second. Sorry. I am not in the attic today because the attic is like 40 something odd degrees centigrade, and we don't have the air conditioning turned on yet. And my home office is at least only in the 30s. Okay, so here we go. So for those of you who haven't checked this out yet, this is Bennu Mappers. And our mission is to do what software can't, and that's to map out this world. Now I'm going to go ahead and launch this and go through an image with you. Now, if any of you had problems before with the screen freezing up, I want to let you know we did a deep dive into the software. Everything was saved. In some cases, some of you managed to save your images over 20 times. One person over 200 times. No data was lost. We have now flagged all the duplicate data. Now, you should find that there are no more bugs. It does occasionally forget to give you a new image. It just gets tired because there's a lot of rocks and boulders. Now, the way that we do this is you can pick any of many different strategies, but the basic goal is to mark the long axis of everything that is bigger and to mark the centers of everything that is smaller. Now, the way I usually discriminate between things that get marked with blue dots and things that get marked with lines is anything that is half a blue dot or larger, but smaller than three blue dots across, I mark with a blue dot. So like this thing right here, it's just a little bit bigger than the blue dot, so it's getting marked. Now, several people have asked me, hey, can you make it so I can zoom? No, I like you. So I very specifically didn't write the software so that you can zoom. And it wasn't just me. I had a huge help. The original software was done by Corey Lehan. All the latest edits have been done by Tanner, who's Herleu in our community. And we did this so that you can't zoom. Because if you can zoom, you're going to be tempted to mark every grain of dust. And really, you only need to mark the things that are half a blue dot in size and bigger. So this is why you can't zoom. It's because I like you and I don't want you to fixate on grains of dust. Now, this is a task that kind of feels like there's no end to it. And the tutorial doesn't quite prepare you for it. when you take the tutorial is going to show you these nice, pretty images that have well-defined craters, just a handful of boulders, no big deal. Well, the thing is, that's what we thought Bennu was going to look like. Bennu does not look at all like we expected. And it's up to us to map out all this stuff, because we want to do a touch and go with the OSIRIS-REx spacecraft and touch the surface with what I best describe as an angry vacuum cleaner, and grab a set of rocks, pebbles in this case, and bring them back to Earth. Now, we have until July 10th to make it through a lot of images. I'm adding about 450 images a day into the system. These are fresh images, fresh from the spacecraft. And starting July 10th, the best possible candidate sites to land, as mapped by you. You're figuring this out. The spacecraft is going to start taking high resolution follow-up images of those areas. So we're relying on you. There aren't enough scientists in the world for us to do this entirely on our own. Like, originally we figured it would take 3 to 5 minutes per image. For me, it's taking more like 10 to 30 minutes per image, except for the rare ones that have really big boulders that are super fast to map. So any help you guys can give, and please, if you know anyone who likes space, if you're part of an astronomy club, get the word out. Tell everyone. We need everyone to help us doing this. Now, I'm going to go ahead and answer some of your questions and pause my marking. And I'm going to bring the dogs up in the background because the dogs are cuter than I am. So, dogs, where are you? My dogs are currently chewing bones and they're happy. Oh, I have a dog chewing a bone. Hello, dogs. There, those are the dogs. Okay, so let's see what questions that we have in the chat. Thank you for donating bits earlier to get my attention that I had like totally... Here. Look at the camera. Look at the camera. I'm spinning the camera. There. Thank you for the bits that got my attention earlier when I completely forgot to turn my mic on. Ooh, scroll is not working. There we go. Looking for questions. Thank you for the more bits, Fenring. Look at the camera. Sit. Okay. Yes, Kerbal. The Soyuz got struck by lightning, but it seems to have gone just fine. That was dramatic. Can someone share the video link to that? Because it's really worth watching. Boy, my computer is overheating. I'm going to have to install air conditioning, I think, or go downstairs. We have air conditioning on the first floor of our house. We don't have it on the second. We just put window units in. I live in an old farmhouse. DPI 209 comments that the hot springs look like they're sulfurous. Yes, I don't know the exact composition, but they are quite yellow. Let's see what else is in here. So Larry asks, how is stellar rotation affected by a companion star? That chart in the second story area for singular stars. Yes, those were only for singular stars. Let me pull the chart back up again. So in the case of singular stars, the rotation is sometimes coupled to the planets going around. Now, if instead you have a binary system with two different stars, the stars can actually get coupled to each other so that they're tidally locked, and one side of one star only ever faces the other side of the other star. And there's all sorts of other combinations of fast moving, slow moving, and everything else. But in the case of stars that are close enough to basically gravitationally disrupt the surfaces of one another, to reshape the surfaces of one another, you do see tidal effects that are quite cool. Okay, so let's see what else. So that one I already answered. Aha, my Wacom tablet is completely confusing. I currently have multiple. I need to unplug my Wacom tablet. Hold on. I use a Wacom tablet when I'm mapping, and it turns out that it was confusing my computer when I wasn't mapping. So Trekker Kev asks, did old accounts get turfed? No. So there are different logins for Bennu mappers, for Bennu mappers and for the main CosmoQuest site, because we're in the process of a major software upgrade, and I didn't want to risk doing anything to Bennu mappers in the middle of the upgrade. There's a blog post up about this on our blog. Basically, Bennu mappers is the old, safe, rock-solid software, and Moon Mappers on Live is using our brand new, we think it has no bugs, but we're not going to risk a spacecraft on it, Python software. So to say that again, because I think I said it wrong, Bennu is built on PHP and Laravel, and it's the prior version of our software. And Live, CosmoQuest.org, is built on Django and Python, and I didn't want to run the risk of doing any harm with Bennu, and so we're running it on a standalone special version of the software. July 10th, we'll be merging the data together, and we'll give everyone the option to bring their Bennu mappers data into the new software. So stay tuned. Okay. So I've been fighting with my mouse. I don't think I missed any questions, but if I did, I'm sorry. So Veronica Cure is asking, does this mean that Earth will end up with its own diamond ring? Do you mean just like the appearance of one in terms of the light going round and round? We will have indeed a ring of satellites going around our planet for a time. Now the thing is, each of these little satellites in the Starlink network, they all have their own little Hall effect drives. They're powered by krypton, and it's essentially a tiny ion drive. And these tiny ion drives mean that all of these little tiny spacecraft are capable of maneuvering. And they're going to be working their way into a whole suite of different orbits, so that instead of having all of them above you in a straight line, there's going to be a swarm of them surrounding the entire planet at any given moment, so that everyone on the planet has a bunch of them overhead, and there's nowhere you can hide from Starlink. This is designed on purpose so that there's nowhere on Earth that won't have access to the internet. So the original reason for building Starlink is awesome, getting high bandwidth internet to the entire planet. but there's some unintended consequences. So yeah. And both of my floofs have moved out of camera. There is a floof over there behind my chair, and there's a floof over there at the door. Looking to see what other questions. Neuropilot says, slightly off topic, but do you think SpaceX will put anti-reflective film on the bottom of the sats so they don't flash too much for astronomers? So there was a tweet yesterday from Elon Musk saying that he was going to ask his team to look into making them less reflective. The concern is that anything that you do to change how bright they are also changes their weight or their function or both. Thank you for the bits. Do you want this? Do you want this? Do you really want this? Sit. Sit. My dogs do not know nearly as much. Go get it. Okay. There he is. Thank you. So I don't know. I honestly don't think that they will probably do anything unless it increases the performance. I don't think they'll do something just to make them darker. Now, that isn't to say that they won't figure out how to make them both more effective and darker simultaneously. So Fenring is asking, have there already been found potential sites on Bennu for the touch and go? So what's been done so far, Fenring, is the mission team using CosmoQuest software went over a low resolution map of Bennu and identified the sites that looked the least hazardous. And those are what you're mapping. These are the least hazardous. We'll be getting to more and more hazardous as we go through the data set. So yeah, you out there, all of you, you're the ones that are finding the place that we're going to do follow-up imagery on. So here's what's been done. There's a low-res map that was mapped out by the team that was used to set the priorities for the images that you're now seeing. The images that you're now seeing, you're our only hope. Based on what you find in these images, starting July 10th, the spacecraft is going to be directed to do higher resolution imaging of the places that look most likely to be safe. And then based on that higher resolution imaging, a final place to do a touch and go, or multiple places to do a touch and go, will be selected. So that's currently the plan. You are finding the potential sites. Please help, please, pretty please. Oh, Lance also donated 100 bits. Can you sit? Can you sit? Come on, sit. Eddie. Sit. Down. There. Okay, he now has treats. Thank you for the bits. Ironheart says, one of the criticisms of the Allen Hills meteorite was that the shapes were too small to be bacteria. Do you think this will be revised in view of the discovery in the first story? So Ironheart, that's actually something I was thinking about. And I just don't recall the size of the Allen Hill meteorite bacteria. Let me see if I can look that up really fast. So for those of you who don't know, the Allen Hill meteorite is a meteorite that, when put through a scanning electron microscope, had structures that were assumed to potentially be nanobacteria. So the structures in this are 10 to 100 nanometers in size. The structures that they're finding in the Ethiopian hot springs are 50 to 100 nanometers in diameter. So these are bigger structures. I'd say that it is more likely that the smallest of these, the ones that are only 50 nanometers across, are going to be found to not be like full bacteria. And 500 nanometers is probably more realistic. I don't know. I'm not a biologist. This is me punting on this, but these are bigger than the ones in the Allen Hill meteorite. So the Allen Hill meteorite is also a meteorite that it has been determined chemically to have come from Mars. So it has two things going for it. It's from Mars, and it appears to have microorganisms for some people's definitions of microorganisms. Now, the problem with it is that it hasn't been replated multiple times, and when they put it through the scanning electron microscope, they had to gold plate it. That's how at that time scanning electron microscopes worked. And there are those who believe that what's actually being seen is just an error in how the gold plating was adhered. So there's a lot of pros and cons working against the Allen meteorite. So time will tell. I'm sure others will be publishing on this. Thank you, Refs Matt, for sharing the lightning video. Neuropilot goes on to say, what would be the potential if Elon put camera telescopes on the Starlink sats? So the issue with putting telescopes on them is because they're maintaining their view of Earth, it would just be very quickly scanning across the sky, so that wouldn't be good for anything. If you put cameras facing down towards the Earth on them, that has the potential to be cool, but they're so tiny that it's not any better than the existing satellites that we have. So really, you're better off using Starlink for what it was designed for, and as was put in chat, paying a Louvois tax and just launching space telescopes in exchange for the harm you've done. That's still a crappy answer, but oh, and Lady Pembroke put in bits. You gonna come over here and say hi? Sit. No, get down. Sit. Smell the camera. Okay. There. Bits for the pooch. Thank you. Thank you. You help me pay Annie when you do that. So Astro YYZ asks, even to say that they will naturally deorbit in 5 years is interesting. Satellites in low Earth orbit can take much longer than that to come down. Yes. Yes. I think it's the nature of how they were built, but we're going to have to see on these. We're just going to have to see. You can say a whole lot of stuff, but what you say and what is true aren't necessarily the same. Thank you, Trekker Kev, for the sub. Here, look at the camera, Eddie. Can you lie down? Lie down. Lie down. Lie down. There. Okay. Happy dog with happy treats. Okay. Sorry about the lag. Yeah, everything here is running hot. Definitely need to consider installing air conditioning. It's hot. Okay, so I think I got to the bottom of the chat. And I'm just gonna end with a note that it's really hot in here. And that's the back of my dog. And we have a world that needs your mapping. We have confirmed the data is always being saved, even if your screen locks up on you. That should be exceedingly rare at this point. Please, please help us map this world. We need you. And if you don't have time to map or have vision difficulties or physical issues that prevent you from mapping, please enlist somebody else. Together we can find. Thank you, Astro YYZ. Thank you. Eddie, be cute. Thank you. Eddie says thank you. More bits. Oh, and Stella actually came over. Come on, Stella. There. All dogs. There. All the cuteness. All the cuteness. Thank you, everyone, for everything that you do, for being here, for helping us map, for helping us do science. Spread the word. Osiris Rex needs your help because Bennu is rocks, on boulders, all the way down. And together, and only working together, can we map this world out? Can we map this world out and find the safe place for Osiris Rex to do a touch and go and find the soil sample it's going to bring back? And we will be giving you credit for everything you do. And I will be notifying the people who specifically mapped out the regions that found the safe places. Don't know who it's going to be. Everyone will get credit for what they do. And everyone will know what they did. So thank you. More bits. There we go. More bits. Happy dogs. Happy dogs. So thank you. Thank you. And I'm going to remind all of you while I awkwardly look for the credits. I'm going to remind all of you that we are a production of the Planetary Science Institute working in collaboration with Youngstown State University. We are a 501c3 nonprofit dedicated to exploring our solar system and beyond. This means that your donations are tax deductible wherever the law allows. We are here because of you. Thank you so much for your bits, for your patronage, for your donations. We bring you new episodes of The Daily Space most Mondays through Fridays at 1 p.m. Eastern, 10 a.m. Pacific. That is 6 p.m. London time. We also bring you the Sunday Science Hour, hosted by Annie Wilson, who is working to colorize Spitzer images and show you how it is that we go from the amazing black and white images that the spacecraft take to the even more amazing color images that you see in news shows like the one we just put on. In addition to bringing you those events, we also bring you live events as they happen, when they happen, unless they happen at 2 a.m. like last night's Soyuz launch. So give us a follow. Follows are free, and you will find out when we are here to bring you a launch, when we are here to bring you a landing, when we are covering the latest press conference. Now, if you happen to miss an episode, that's okay. We archive everything over on YouTube. Please consider giving us a subscription over at YouTube. It really helps us out getting found and rising to the top of those search results so that we can bring real science to anyone who wants to learn. Now, I regret to say that the credits are always hard to find, and Streamlabs likes to move them. So I'm now going to run the credits, and then I am going to find somebody to raid. If anyone has any suggestions on who to raid, Speak now and make my life easier. So, that's all I've got. Wherever you are in the world, have a fabulous morning, evening, afternoon, and if the weather allows, go outside and look up. And I will see you on the other side.